We're going to have your presentations on stage. So when your group gets called up, if you can bring your flip chart on the stage and present it from here, please. We're going to start off with Layer 2, sewer systems. That was in the breakaway room. I'm not sure who's going to be doing the presenting. Remember, you'll have 3 minutes to do your presentation. Okay, everyone, let's start with the feedback. Our first one is going to be on sewer systems, Layer 2. And sir, if you can introduce yourself, and then you've got literally 3 minutes to do your high-level presentation. Thank you.
Thank you. So hi, everyone. My name is Benny Rousso. I work at Deakin University as a research fellow, leading a research program with Barwon on smart sewer systems. So I was quite happy to see many people interested. We've been talking a lot about smart water systems, how we can add new instrumentation to improve operations, billing, leak detection. But it has been really interesting and fun to see that there are people as well here interested in knowing how can we use new technologies to improve operations of sewer systems and everything that are related with them. So the first thing that we talked about was what sort of applications would be useful from smart sewer systems, considering the South African and the African context. So we identified some of the applications as integrating sewer network operations with wastewater treatment plant. Lots of the things that are happening in the sewer systems are assumed or expected to be occurring as designed, but not necessarily this is what is happening on the ground. So having instrumentation and monitoring that will allow us to know what is the flow, what is the water quality in different parts of the network can inform how the operations on a wastewater treatment plant should be. Identifying hotspots for problems that are occurring in the network, such as spills and blockages, so the utility can target their resources and interventions in a more effective way. This is linked with the first one that I mentioned, but really understanding the hydraulic behavior. Again, most of the behavior that we see in sewer networks, we assume that is what is happening. Measuring and monitoring the flow in gravity sewer pipes that are not pressurized has not been done consistently. So this is something that will be useful. Integrating with billing. Billing for sewer systems, wastewater systems is usually associated with assumptions of drinking water consumption. So having accurate measurements of how much water is flowing through sewer systems to inform the billing would be useful as well. Water quality compliance for industrial consumers. So if you have an industry, you might need to adjust previously to connect to the sewer line your effluent so it can meet the criteria that the wastewater treatment plant is adjusted to. We identify a couple of drivers and enablers as well. So the first thing that we saw is good quality data. Really understanding what is happening on the ground is something that would be tremendously useful for operations and also strategic planning of resources and interventions. One of the key drivers for instrumenting and optimizing operations in sewer systems will be regarding compliance. So whenever there is a spill, it's something that erodes the image of the utility, but there are financial consequences as well. And sometimes the consequences can be even jail time, as reported by some of the people in the table. As well, a key driver will be to take care of the communities as a social responsibility of the utility, and something that is aligned. 30 seconds? Okay. So I'll jump into the key takeaways. In the South African and African context, there's a high rate of illegal dumping. So it's seen that having more information about what is happening in the sewers can really inform community engagement to understand what are the challenges in terms of operations. And this will be a great need to reinforce the value with communities so they can understand that what happens in the sewer lines is not completely dissociated of their behavior. Again, targeting interventions with the community, but also reinforcing the value of why you should behave like this and for them to understand the enforcement that needs to be put in place. And lastly is the high value of the evidence. So really understanding, again, reinforcing the idea of having more information about what is happening in the sewer systems can inform multi-sectoral interventions going from solid waste management, stormwater optimization, and also operations in wastewater treatment. Thank you.
Fascinating. I'll give one person a chance to either ask a question or reflect on what they've heard. One person. Any takers? Hands? I should have warned you beforehand so that you could have paid more attention to what he said. But for the next ones, for sure. Round of applause, please. Thank you very, very much. Yes, and just place it down there for me, please. Can we have data management and display? Layer 4, is it? That number is 4, data management and display. Your 3 minutes starts now.
Afternoon, everybody. My name is Fezile Solombela, part of the HR team for water and sanitation, City of Cape Town. So we looked at layer 4, which is data management and display, and we had quite a number of really robust discussions at the table around it. So we first brainstormed as to what we think. So we put a number of points and look at the lack of the system integration. We looked at cyber security that's not really defined when it comes to data management. We also looked at the transfer of data. How is data transferred in terms of service provider to a utility? We also considered the roles and responsibilities, right, between the service provider and obviously the end user. And we looked obviously the presentation of data, because part of it we looked at the visualization as well. So having identified all these number of issues, we looked at what were the current challenges when you look at data management. One of them obviously being legislation. You look at POPIA as an act. That's quite a big hindrance. We looked at whether the integration of the platform, so having an organization with multiple platforms that don't quite integrate to one another is also quite a hindrance. And also the presentation of the data, whether it's user-friendly, it can be looked at, one can make a decision around that particular data. We then took a look at the opportunities, right? So what opportunities lies in us managing that data? We look obviously at upskilling the internal talent, so the people that are going to receive this type of data, can we upskill them to enable them to interpret the data? We looked at obviously the role of evidence-based data, so using data as evidence in decision-making. We also look at the empowerment of the end user. So because we're servicing external clients, how do we empower those end users obviously to make use of that particular data? Thank you. We then looked at the solutions. So what solutions can we put to the table in terms of us going forward? Number one is obviously a strong leadership around governance. So governance plays a very critical role in terms of one of our solutions. The policy framework, the frameworks around policy, if you look at the POPIA Act, how does legislation and what reforms could be there in order to make sure that the integrity of data is maintained and also the management of data is better done. The change management journey. We heard this morning a lot about change management, but we then unpacked to say, but change management is not a one-stop shop. It's a continuous journey, and in most cases, this can also break or make your processes. We also identified the role of stakeholders. So each stakeholder must have a role to play in terms of the data, because ultimately there are multiple users of the data. We also looked at the centralized system, right? Rather than having multiple users, look at a centralized system, which then can say, if this person needs the data, he's got authority to see data up to a certain level, and then obviously then it cascades upwards in terms of the usage of that data. And then obviously make sure that data is generic, so that it's user-friendly, right? Having very complex data ultimately is not user-friendly and makes the whole process of decision-making very difficult at the end. Right, I think that's my story.
Wow, he saved me 30 seconds. So any comments, reflections on this presentation? No? Everyone happy? Don't want to add anything? Don't want to rubbish some of it? Nothing. Okay, cool. Well done. Congratulations. Thank you very much. That was a presentation on data management and display. The next one is on, is it collection and communications, Amir? All right, collection and communication. Who's doing the presentation from this group?
Sergio.
Sergio is doing the presentation from this group. Hello, Sergio. There's a microphone for you. And your 3 minutes start now.
Hello, everybody. First of all, let me thank the team with which we did the work. So the outcome, it's about communication and data collection. So when we speak about communication data collection, we need to understand what data we want to collect and what data we want to transport. So first of all, what was important as an outcome that we could extract from the discussions is that data need to be scalable, because those investments are done over the decades, and some data are available today. Maybe tomorrow, in 10 years from now, you may need additional data which might not be available today in the device. So you need to have device upgradability. Then you need as well to characterize the install base, because as you are starting to deploy the digitalization, you may rely on different manufacturers, and you want to be able to characterize the performances by manufacturers in functions of how the devices are deployed. In fine, the push-pull, either you are pushing the data or you are collecting the data. So depending on which direction the data exchange is triggered, this is something very important, and it has to happen by data type, because there might be data which can be pushed, like the consumption every once a day, but there might be alarms which are different in an hourly basis, which you may want to retrieve in a different way. Then the data granularity. Typically, the vandalism and alarms, these needs to be transmitted immediately, while the consumption can be done on a daily basis. And here, it was interesting as an outcome is that the data quality is something that can be used to trade off the battery life. So people are eventually open to consider a shorter battery life if they can get access to a much better data quality. Then the point that was discussed was where analytics should be done. Should we collect and transport all the data that the smart meters are producing? Or can you think of doing some edge analytics so that you are processing some data at the edge and you only retrieve the metadata that you are analyzing at the edge? And here, an interesting point is that there is some collaboration that can be foreseen in between public utilities, the water public utility and the electricity public utility, where eventually you can use the capability of the electricity smart meter to do some edge analytics, and eventually as well to reduce your bill, your OPEX bill for the data transport cost, because you can share those costs with the electricity public utility.
5 seconds.
The last 2 points, the communication data architecture. The data model should be agnostic from the communication protocol, so that if over time you are evolving with your communication protocol, you don't have to reinvest money for your IT infrastructure. Then the standards, so those protocols need to be standardized to be part of a global standard, but take into consideration some regional specificities, particularly those which are mandatory because of the local legislation. And in fine, the cybersecurity. The last one. The device to application encryption and the device certification with possible device attestation certificates.
Sergio, thank you very, very much indeed. I thought I would do it the same way as they do at the Oscars, where they have the bed sort of coming underneath to indicate that your 30 seconds is up. Good, sir. You are standing on form and ready for your presentation. Which layer are you? AI. All right. So it's data fusion and analysis, AI. Your 3 minutes start now.
Thank you. I'm Vineet Mishra. I'm from EY. And you can understand the severity of the matter that EY and Henny called me up from EY India. to share my experience and what we discussed with our teammates on this. So how we structured our thought that we discussed top 4 or 5 challenges, how AI will do that, and whether really a huge investment required or not. I'll take 2 minutes. And last 1 minute, I will like to push on very pressing point, which we need to consider because 15 countries, 93 organizations sitting over here, if we can think together, we can really leverage the power of AI. 4 to 5 use cases we discussed. Non-revenue water, which contributing 40 to 50% contribution. Here we are using smart metering data analytics. We can plug out, we need to think beyond only smart metering data analytics or AI. We need to think we can go for a better system planning. We can go for better revenue forecasting. We can go for a better revenue assurance. Second important aspect, which is very pertinent, it was highlighted that different data sets are sitting, how we can run AI. So organization needs to think first to create a data lake. If you are able to create a data lake, from last 2 days we are hearing that we are not having a right set of our data. Data lake can put all kind of checks and balance in the system, whether you are generating right set of data or not. If you need any data massaging to create data lake, you can do that also. If you start building up data lake from today itself, you will get the advantage in the future. Third, legacy infrastructure. So predictive maintenance, which is a classic case of AI, you can utilize that for your aging infrastructure, be it meters, be it pipelines erosion and leakage because of those. So that is a very common issue. Predictive maintenance will give you insights when your asset is going to fail. And most importantly, the point which I was discussing, predictive maintenance, my colleague highlighted very point that we are living in the reactive maintenance mode, not preventive maintenance mode. So we need to come out of that mode. We need to use AI for predictive maintenance. Revenue assurance, again, a very highlighted point, which would be covered largely through smart metering prepaid. If regulations allowed, we can go for a smart metering prepaid. Last but not the least, water quality. So AI is playing a significant role in water quality to identify contamination or predict if water is going to be contaminated in near time or not. So there are automations are also available. Based on the AI prediction, you can put the right set of automation. So these are the 5 use cases which we discussed, 5 challenges. I think it would be less than 2 minutes, almost.
Well, less than 3 minutes, yes,
So
but above 2 minutes.
last point which I would like to highlight, I have put one abbreviation here, which is AWS. We need to put emphasis on this, and I'm very keen, Amir, we would like to publish a thought leadership on this concept with you. That is Africa water stack. If we can think over it. I'm taking an analogy for IES, India Energy Stack, where 85 distribution utilities, energy utilities are coming together. What would be AWS? If City of Cape Town is developing one particular AI use case, any or municipal corporation can leverage that without putting efforts, without putting additional money, without putting time. You use one use case, common protocol, put in that through GitHub or any repository. Every municipal corporation can utilize this. Thank you. Thanks a lot.
Yeah, that's a very good idea, Vinay. Thank you very much for that. Can we have sense and control water networks coming up, please? That wasn't you, right? No, you were AI. I'm done with you. Thank you. Who did water networks, sensing and control? If you can have your presentation up on stage, or are you going to just do it from your notes? That's brave. That's good. That's cool.
That's why we so late.
Good point. Your 3 minutes start now.
Good afternoon, everybody. Can everyone hear? So we were speaking about the sensing and control of water networks. So we had a good mix of international and local delegates in our group. We had people from the UK, from Japan, from Uganda, from Namibia, from Botswana, and then quite a few members from South Africa. We covered suppliers, consultants, municipal employees, bulk water suppliers, and was a really great interactive session that we had. So we spoke about data logging and sensing and control, where we sense, pick up data, and how we actually use that in the control mechanism of water networks. We then spoke about the importance of technology, and the discussion then took a very interesting turn, where everybody started to come with anecdotal data of skill sets and skills and what we needed in water networks and how there was an apparent lack of it. Some examples given were things like supply chain management, where they don't understand a water meter. So they're essentially looking for the cheapest water meter, but operation is looking for the most valuable item to enhance revenue services. You had questions of internal governance that didn't understand national treasury requirements, and as a result of that, budgets weren't spent and money was sent back to national treasury. Operations were not understanding the assets installed in the ground. PRVs and pressure management equipment wasn't understood. You then had scenarios of a CFO not understanding the benefits of pressure management and how, in fact, with reducing non-revenue water, you could actually build up a revenue enhancement project, because instead of just selling more water, you could be saving on the water that was actually being lost. So from our session, the biggest key takeout was enhancing skill set or the human capital across all levels, not only from the operation side, not only from the management side, but from politicians to CFOs to management to everybody accountable in a water network and in a municipal structure, where we actually start looking at more investment in the human capital to get more value for our money. That's it.
Wow. Okay.
Thank you.
You get the prize for the most efficient presentation, without a doubt. Another round of applause, please, for sensing and control water networks. All right, can we have data fusion and analysis digital twins, please? Data fusion and analysis digital twins. Coolest outfit, man. Without a doubt. So he gets the prize for the most efficient presentation. You get the prize for the best dressed.
Hopefully there's something for the presentation too. So, welcome everyone. It's great to be speaking to you a bit about digital twins. That is what SAN Technology specializes in. I guess a bit of an introduction in terms of like what a digital twin is for those who haven't heard the concept before. It's the software idea of replicating behavior in the real world. So ideally you want to go through the idea of real-time visualization, the ability to simulate what would be and then to essentially go the next step and to start optimizing processes, but all based off of replications of real world behavior. So where our discussion started was in the idea of really, we're talking about digital twins, but are we data ready for those digital twins? We spoke about some of the data sources that exist. We expected there to be some level of a normal distribution of how many data sources do you deal with, and we ended up with something more of a double cluster. So we have an identification of somewhere between 6 and 10 data sources over here, and 50 plus data sources here, and we got onto the discussion of ambiguity as to what is the definition of a different data source. So just having this idea of needing more consistency in our awareness is a very good starting place. Then thinking through the idea of where are you in your data journey, from going through from this idea of what we called a mixed masala, or data is originated, then we go into data products, but there's a bit of disorganization within these siloed data products. We want to move forward into federated data and be able to really have strong governance processes and policies and really understand where people were within their journey in our discussion group. We then went through into the circular framework, and we were talking about, right, digital twins are these really cool new concepts that are coming through, really powerful to have, but all of the problems that you are dealing with at the moment, where do they fall within this framework? And a vast majority of them are, well, actually not really clustered. They're spread out throughout the entire value chain. So starting with the physical assets, just making sure that we have the right data being measured, that it's communicated across, that it's aggregated in reasonable ways. And then we had these fold-over concepts that encompassed everything of data governance policies, and essentially what's down here is people, process, and technology as we're thinking through this value chain. Which then moves us through to frameworks that we're considering as we're thinking through the next steps of the solutions. DCAM, Agile Pods, Spotify Model, CRISP DM, a couple of different considerations as to how we would go through a solution framework, and then into what these solutions need in order to succeed. So I think I'm going to jump straight into what it takes to fail, which is we're thinking about this, all of those previous fail cases and challenges that we put down on those sticky notes really can be summed up into garbage in, garbage out. If you have any level of unreliability within your system getting through to your digital twins, you're going to have issues. And likewise, you don't want to jump straight into a digital twin if you're just trying to solve a much more simple problem. So don't bring a gun to a knife fight. Just think through fundamentally, what is the problem that you're looking to solve? Maybe it is a digital twin that'll help you with this entire value chain, but not if you haven't solved all of those previous steps within the circular framework. And fundamentally, to make sure that the solution is landing well, you need to have a use case. There's always going to be this division between you want so many precursory steps to be in place in order for a digital twin to be successful, but also in the digital framework, we really care about having an MVP. We can't just jump into the complexity and be pushing all the way through, have so much capital investment to get this concept across the line, but it's taken us 2, 3, 4 years to get there, and by the time we deliver, the use case has changed. Top-down buy-in, we need to make sure we understand what we're dealing with, and we need to make sure that we are incorporating the right people in the processes. Thank you.
Stunning. Thank you very much. A round of applause, please. A reminder, of course, that if you can, please do share those notes on the SWAN forum. We'll remind you how to do that, and then we want to be able to share this with the rest of the delegates and the participants as well. And then my final one is data integration, right? Data management and display, data integration. If you can come and make your presentations, please. You can do whatever you would like.
Thank you. Okay, good afternoon, everyone. So we are layer 4, data management and display. We focused on data integration. Our roundtable was led by SAP. I think I'm too short to flip these things. Yeah, all right. Our roundtable was led by SAP, so I need everyone to clap for me when I'm done because drinks are on us. So when we started, we looked at the challenges that come with data integration in the water sector. So the consensus was that integration is important for building any data-driven organization. The main challenge noted was that data is often siloed across systems and fragmented, which makes it a bit difficult to use. Some of the other challenges that we noted were, lack of standardization when it comes to data in the water sector. We have different vendors, different manufacturers, all using different types of communication protocols. We have devices that communicate differently. We struggle a lot with poor quality data, and data security is also still a very big challenge with our data in the water sector. And we also have limited data sharing across data solution providers. I am too short for this. Okay, no, I'm gonna rely on my notes. It's fine. Thank you. All right. So from the challenges, we looked at what opportunities are there with data in the water sector. So with a lot of advancements in the sector, we noted that there are a lot of opportunities when it comes to data integration. So opportunities include the fact that we now have cloud platforms that allow for scalability. We are no longer limited to inside data servers, so there is a lot of opportunity for integration. We also looked at standardization, so learning from other sectors. We know that in the energy sector, they are ahead of us in the water sector, and they already have models like common information models that is being applied currently in Belgium's water sector, something we can learn from, and just the importance of understanding that we need to use the data that we get and not just collect it. Yeah. So another key finding was that when data is integrated properly, organizations can start unlocking insights from it. Our key takeaways. Thank you. So some of the key takeaways from our roundtable is that organizations need to move from simply collecting data to actively connecting and using it. Some of them were moving from siloed data to connected data. We need to collaborate as well, and that's an opportunity that data also brings because it can connect different teams and different people in different divisions. We also looked at people being overwhelmed by data because we know that data comes with a lot of volume and velocity. And we spoke about the importance of organizations having a data or AI strategy before they even think about integration because it looks overwhelming because people don't really have the end in mind when they start speaking about data. I think I covered it. Thank you.
Thank you very much. Do you mind putting it on the table there for me? Thank you. I so desperately wanted to use this wonderful flap, which means enough, let's move on, which Amir had given it to me. But then you mentioned that drinks are on you this afternoon, so I decided not to use it. Another round of applause, please, for our final presentation. We're going to break for tea now and ask that you be back here at 4 o'clock for the next keynote, which is on how to embrace digital technologies for improved water services. We'll be looking at Muwasco's smart water journey. It will start here at 4 o'clock. Thank you very much for all of your presentations. Once again, please share the notes on the SWAN forum, and then we will definitely make sure we share it with the rest of the participants. See you at 4.